have laminated the roof. And tilted all this massive piece to make more room for making the walls, which is the next phase.
As you know from before, we did this resin infusion sandwich test. We're gonna make each wall section as a resin infusion panel, and then we're gonna trim them and then glue and laminate them together, and also laminate them into the roof. And when that is done, then we will use the walls and the roof as a mold, kind of, for the beam, which we plan, as of right now at least. That might change, a lot of things change during the process, but right now we plan to make the beam as a resin infusion in place directly to the part. So to do this, the wall panels, we needed a flat surface, preferably glass, to run resin infusion against. So we bought this table second hand, got it quite cheap. It was very difficult, to say at least, to get it here. It was a bit more heavy than we anticipated.
Almost impossible for me.
Anyhow, it's a really good surface to make the resin infusion on. So now we're gonna start to prepare the layup for the resin infusions. It's gonna be 5 resin infusions, so it's basically one wall here-ish, one following this face, one following this face, and on this side and this side. So it's 5 sections. Let's start doing...
Prep resin infusion.
Yes, so this will be our first piece that we're actually gonna use. We need to prepare this one as well.
Yeah, with some release agent.
Yes.
And clean it.
Let's get going. Okay, so we're starting with the layer of peel-ply. Normally I'm not sure what's normal, but I guess if you want to have a nice surface against the glass, a nice flat surface, you wouldn't do that. But as we're gonna laminate on both sides of this panel, when we laminate it in position to the roof, we want a good bonding surface. We tried this setup on the test piece we did, and it turned out really good. So we'll do it like this again. We placed one 2x2 twill 280 gram mat, and then we had this 600 or 650 gram biaxial. I'm not sure if we are sub-optimizing here. I mean, obviously we're going to cut away a lot here because it's going to be a big window in the middle. Maybe we could have just put one piece all over the whole place, but then we need both fiber and resin for this middle piece. I don't know. Let's see. Maybe we're sub-optimizing now. I don't know, but let's hope not. I'll show you later how we will place the resin feed lines in the vacuum, but just before we place the core, is that obviously this one is a bit bigger because we will trim it down when it's done. We're not gonna do any chamfering of the sides, except one side that we have just chamfered very, very ugly quickly, and there's a reason for that.
So now the mesh is in place, and the mesh is for making sure the epoxy flows under the vacuum.
Exactly, so giving a channel for the resin to flow in. And now we're placing the resin feed line. Soon we will try to explain why we place it like this. Okay, so the resin feed line is placed. So the idea is that we're going to have the resin input here. It's going to distribute on both sides, and we place the resin feed line here now. But as we don't have any chamfer in the core here, it would be like a racetrack. It would be like a channel for the resin to flow along the side anyway. And also, this is just guessing or predicting, trying to predict. Let's see how it ends up in reality. But anyhow, so then the idea is that it's gonna flow from both sides, and we're gonna have like a flow front, like a V, along the paddle. And then we chamfer this side to not get too much racetracking on this side, along this edge. But we might get it anyway. We don't really know. And that's why we have a bit of a special vacuum port here. So we don't just have one point where we'll pull vacuum. We'll have this. I'm not exactly sure what it's called. It's a strip with this membrane that is allowing vacuum over this whole surface, even though we will have resin reaching some point of this one. So let's say that we'll have resin that will come through here, and we'll create an air void inside. Vacuum will still be pulled over here, so we'll be able to pull that void out. So if we would just have a vacuum port here and have that scenario, we might actually get some air trapped inside. We have never used this before, and we plan to use it later on when we're going to do the beam, which is a more critical part. And then we thought we might just try it now. And it's going to be very interesting to see how the flow front propagates here. Also, we're a bit unsure about the actual distances there. I mean, this piece is like 1 meter wide, so we're really on the limit of what I think you normally say that you should have maximum half meter from feed line to vacuum port, which we effectively get here now, but it's a bit on the limit.
We have now vacuumized everything, and it seems to be tight.
I think I'm mostly interested in to see how the flow front is going to be here, if the prediction holds. So a lot of calculations ongoing.
How much resin we're gonna use?
We'll do it in 2 batches, everything as well. So we'll make 1 batch that is like, what is it, 80% of what's calculated to what we should have?
Yeah.
Because we don't have buckets to mix everything at once.
Maybe we don't need everything.
No. So then we need to make a decision halfway or midway to see how much extra we're gonna mix.
Because that's a good thing about this method is that you can clamp it.
Yeah.
And stop the process and mix more epoxy.
Yeah.
But the biggest batch first. I'm not sure how fast it's gonna go or how slow.
The actual infusion, no?
No.
Okay, we're good to go.
Yeah.
Okay, so first wall panel done, and I think it went good.
Yeah, but we have some things to take with us to the next piece.
Yeah, we didn't really get full symmetry on the feed line here. On this side it ended up very close to the core. That resulted in that it didn't really release resin as good as when it's free on a flat surface. And they were also a bit unequal between the sides. So we got, yeah, you can see the flow front pattern here. They went a bit faster on this side than on this side, resulting in that we ended up with some air here in this section. Because what happens with this strip is that as soon as resin hits it, it blocks resin, but it also won't create any more vacuum anymore. And when the flow front hit the side of this obviously whatever was left here didn't come out in terms of the air that was left. It seems like it wetted anyway, but it's not really a huge problem because here this will be the side that goes towards deck, and here we will have a cutout for the hatch, companionway hatch. How long time did it take?
I think it took around 20 minutes.
Somewhere between 15 and 20 maybe.
Really cool. So tomorrow we will open this.
Yeah.
Time to open up, and the release agent seems to work so far. Very fine at least. Just come everything. Whoa! Wow! Next piece we're making is one of the sidewalls.
Okay, so we're working with the layup of the second resin infusion of our walls. I think we mentioned something about it was tight the last time. That was not even close to how tight it is right now. But we knew, I mean obviously we tested this in the CAD before and we knew that it was going to be tight. Since then we have also added this. Maybe we should have shown this before, but there's a flange here, like that's 8 centimeters more than the actual wall going to be later on, and that's because we will use that for when we're gonna do the actual beam, which will come up here. To have somewhere to put the tacky tape and have room for all the stack up. Yeah, so I mean this is gonna be, as you can see, the tacky tape is actually on the edge here, on the table. It's probably not ideal at all, and the risk of leakage is way higher than before, but I mean it's the only way we can actually fit it, so.
Yeah, we're gonna test it to dry first, and then we will do our best to, we must do our best to seal it.
Yeah, and also on this edge we will have the feed line hose going around there. It's like, I don't know, 12 millimeters.
There was
not
a
ideal.
lessons learned from last time that you shouldn't have it too close to the core, because that was weird, but hopefully it won't matter that much because it's in the beginning.
Yeah.
So it won't be as critical as later, and then have it
further out later on.
Yeah, when there's more room.
Yeah.
Now it's time for peel ply and then the mesh, and then start to sealing it.
Yeah.
It is time.
Okay, so second panel infused. It started off quite bad.
Yeah, very nervous.
Yeah, we only placed mesh on top now and no mesh on the sides. So the resin distribution hose was not laying on any mesh. It was just on peel ply, but we placed it very close to the edge. So we thought that okay, that would be enough for the resin to bridge over to the mesh and then flow on the mesh. That didn't work out very well. It was a really like a resin break, and it was just in some spots where it started to distribute up to the actual laminate. So
but we managed to get it up. We pushed actually the spiral hose a little bit closer to it, and then
yes, we tried to manipulate it, get it closer, and also get like the bag to open up a bit.
Yeah.
Kind of, and then that worked out, but it was definitely not good, I would say. I think we should really have mesh going down, but we did that on the first panel, and then it felt like it was
too fast.
Yeah, but it's also I mean the mesh does not really conform very well over the edge, and we're not chamfering the edge here. Obviously a chamfered edge would be the best thing, but I'm not sure. This one took way longer than the first game, but it completed.
Yeah.
And you can see the flow fronts, how it propagated, so I mean I think it propagated quite good. We didn't get any trap, and I'm not sure if we said anything about this, but we did another test here with the import. So last time we used this strip, which was nice in some way, but the problem there was that, I mean, if we didn't place the strip exactly where the propagation front met each other, I mean, or let's say like this, we placed it a bit off-centered from where according to propagation front. So we had one front crossing the strip before the infusion was done, and then we closed. Yeah, we closed a small air pocket then. But there we did just like a resin break with the peel ply. So we stopped with the mesh on the part, and then we just had peel ply in the end. And what happens then is that the resin propagates very slowly over the peel ply. So it kind of, you will basically have vacuum over the whole side, more or less, unless it closes, so that the resin goes through here before it has propagated over the part, which we were quite close to.
Yeah,
do. I mean,
that was.
We only had this small opening here in the end, so I was a bit nervous, but it is.
So maybe we should have chamfered this end here to slow things down.
Yeah.
Here maybe don't have the spiral hose. Now it ends here.
Yeah, we should maybe have it a bit shorter.
But it's a bit fun, right? It's a process improvement.
Yeah.
Next piece will be exactly the same.
Yeah.
So then we can
improve.
Yeah,
maybe.
improve, hopefully. And then the last piece will be, and then we have the beam, and then we're experts. No.
Maybe not at all. So the third wall panel is done, and this time we let the mesh down on the sides, which you should do, and I think that made some difference. I mean, it was more and more even distribution when it went up to the panel, but it was still very slow. So I think that's more about the size of the panel. I think.
Not as nervous for us.
No, it was more under control this time, and we also left a bit of like a, I'm not sure if you call it like a resin break. Yes, we left the mesh just 3 centimeters from the edge of the panel, and that made, I mean, you can clearly see it on the lights, it really stopped the flow very effectively. So in the end we almost entered the edge at the same time. So all wall panels are now done, and the next step will be to trim them to their exact shape, and then we're gonna start to position them and glue them in together. Yeah, let's get cutting. We are ready to start to mount the walls. I think we'll first glue them in to be able to create the fillet in the corner with some thickened epoxy, and then when that has cured we will laminate.
We have started positioning the wall sections into the roof, and yeah, we have some in place. So here we are, trying to get every angle correct and in place, and there's a lot of them.
Yes, it's almost like it would have been easier to just make everything in place. Okay, so all the wall panels are now glued together. It was quite tricky to position them all, and I mean the whole idea with the Resin Infusion thing of all the panels was that we were going to have like flat, stiff panels that was quite easy to place and glue together. And I mean, this one we will need to laminate together with some more layers as well. So in hindsight, I'm not really sure that it was really the best way to do it. It's hard to know. I mean, the other way would be to try to build some kind of mold or something that would hold just the core and then laminate everything in place. But we thought that, I mean, the core, they are so non-stiff and wobbly, and it felt like it would be very tricky to get everything straight and flat and in position. But this also took, I shouldn't say that much time. I mean, we did all panels in less than a week, just on the evenings, so it wasn't that long. But you know, it's quite a lot of consumables, materials to do it, and so on. For just doing this part, maybe it would have been easier just to build like some kind of mold or jig to hold everything in place and laminate everything in place. But we wanted to do the Resin Infusion to practice and learn about it, because we had never done it before, and to really get a successful job when we're going to do the carbon beam later. I mean, first of all, we think it's very difficult to do a hand layup because it's very different shapes or difficult shapes, and the carbon is very stiff, and we're going to build a thick laminate as well. So just by hand laminate, I think it's very risky that you don't really get it good. A vacuum bagging could be an option, but it's also a lot of layers that need to be wetted within the pot life of the epoxy, and that's also a bit risky, it feels like. And then you have vacuum infusion, which if everything works good, it will probably be a really good result, but it's a big risk in that we fail in the actual resin infusion process. So that's why we wanted to learn and try it out a bit on these ones. I'd say we know a lot more about resin infusion now, and that's good. It feels promising for the beam. Okay, so all the wall panels are now glued in place. The next step will be to laminate them in as well. So we'll both laminate wall panels to the roof and also laminate the joints between the wall panels. For that we bought some new glass fiber. Now we bought a tri-axial 600 gram glass fiber. So it has both fibers in one direction along the sheet or roll or whatever you call it, and then 45 degrees to that one as well. So basically we will do strips basically, and depending on the placements we will do some strips. So we get these the long or the fibers in the roll direction with the joints, and in some places we're going to do them across the joints depending on where we are basically. Not sure how much that will actually differ in the end, but yeah, that's the idea. I think we'll only start to do the inside of the walls, and then we'll do the outside later. Just put on this pipe, that will be the extension for where the electrical wires will go to the solar panels and the downlights that we're gonna have here. So this will be exactly on the side of the beam, so the beam will go up here.
We are currently finishing everything we need to laminate the walls for the doghouse. So
preparing all the parts,
cutting some peat light.
material.